Good morning everyone. Today in this live lecture we shall solve the non-linear partial differential equation having a independent variables are more than 3. So there is a special method to find the solution of a non-linear partial differential equation having a more than 3 or more than 3 independent variables. Actually, Charpit's method is the method in which we can solve the non-linear partial differential equation whose that includes 2 independent variables. So the Jacobi method is a more general than the Charpit's method. Okay, so we shall solve the problems based on this. I shall revise this Jacobi method. If the partial differential equation of order 1 having a 3 independent variable f of x comma y comma z ux uy uz which is equals to 0, then we have to introduce 2 new functions, capital F1 of x comma y comma z ux u2 uz a, capital F2 of x comma y comma z. We have to introduce 2 partial differential equations, that is h1 and h2. 2 partial family of 1 parameter partial differential equation, and then solve 1, 2, 3. You have to find out the values of ux, uy, uz. Put these values of ux, uy, uz in terms of Pfaffian form of differential equation and solve this differential equation, which gives the result, which gives the complete solution of this partial differential equation 1. This is the method. This is the general idea of the solution of the Jacobi method. Okay. Now these are the very important note regarding the Jacobi method. First of all, Jacobi method is used for solving partial differential equation having 3 or more independent variables. Main idea is to introduce 2 or more 1 parameter family of equations. Then these are the partial differential equation which is in the form. Here we can write in the another form f of x1, x2, x3, x4, p1, p2, p3, p4, where p1 is equals to dou u by dou x1, dou u by dou x2, where u is the dependent variable. Okay, already we have discussed this. This is the Pfaffian differential equation. This is the condition of the exact. This is the Jacobi's auxiliary equation. Okay, this is the condition for the compatible. If h1 and h2 are the compatible with f, then we can write this condition, or this is also another condition. Now working rule for Jacobi's method to find the solution of a non-linear differential equation. See this. Consider a non-linear partial differential equation of order 1 with independent variable, with a dependent variable z, or we can write u, z किंवा u लिहा, and x1 comma x2 x3 in this way. So it takes the standard form f of x1 comma x2 x3 p1 p2 p3. So we can write p1 is equals to dou z by dou x1 plus p2 is equals to dou z by dou x2, p3 is equals to dou z by dou x3. Or we can write in the another form. याला आपल्याला दुसऱ्या फॉर्म मध्ये सुद्धा लिहिता येतं. f of x y z ux uy uz which is equals to 0. In this case, u is a dependent variable, x y z are independent variables. So here u is equals to ux means dou u by dou x, dou u by dou y, uy means dou u by dou y. In the second step, write the Jacobi's auxiliary equation. Already you know that Jacobi's auxiliary equation, this is the Jacobi's auxiliary equation, or we can write for this type of a function, we can write this Jacobi's equation, or we can write this Jacobi equation. If there are 3 independent variables x, y, z, then in this form we can solve easily. So for 3 independent variable, you can write this Jacobi equation. If there are more than 3 independent variable, then you can generalize this. So we have to take the additional functions, additional equations, f1 of x1, x2 or h1, you can take h1. These are the additional functions, and in the step 3 verify f1 comma f2 is not equals to 0 by using this. परंतु आपण ही मेथड वापरणार नाही आहे, फक्त सोल्यूशन प्रोसेस लक्षात ठेवा. f1 comma f2 which is must be 0, then there exists a solution for f1, f2, small f1, capital F1, F2, or we can write this is h1, h2. This is also written as h2. तुम्हाला जनरल करून सांगतो मी, h2 equals to x, y, z, ux, uy, uz, which is equals to 0. So we have to introduce the second function, that is h2 is equals to h2 of x, h1, see this h1 x, y, z, ux, uy, uz, which is equals to 0. आता ॲक्च्युअली या थर्ड स्टेपची गरजच नाही, ते ऑलरेडी 0 असतंच, कारण कंडिशन ऑफ द एक्झॅक्टनेस आपण पाहिलेली आहे. सो यू कॅन चेक दिस अँड देन पुट द व्हॅल्यूज ऑफ ux, uy, uz in the Pfaffian differential equation and solve it. We will get the solution. आता working procedure, if there are more than 3 independent variables, suppose that x1, x2, x3, x4, there are 4 independent variables, and suppose z is dependent variable, or you can put u is the independent variable. Sir, suppose जाईल तुम्हाला u लिहा. If there is a u is independent variable, so it will be dou u by dou x1, dou u by dou x2, dou u by dou x3, dou u by dou x4. So P1, P2, P3, again you have to follow the same cases. We have to introduce 2 different functions, 3 different functions for this. Write down the Pfaffian differential equation, introduce 3 different functions. We denoted as it, तुम्ही थोडं बदलून घ्या. It is denoted by h1, this is a h2, this is a h3. Introduce 3 different functions. Then calculate P1, P2, P3 and put these values of P1, P2, P3. This is not necessary to check this. Put these values of P1, P2, P3 in this Pfaffian differential equation. हा जो Pfaffian differential equation आहे यामध्ये ठेवा. So dz is equals to, or we can write du is equals to P1 dx1 plus P2 dx2 plus P3 dx3 plus P4 dx4, and solve this Pfaffian differential equation. We will get the solution of given differential equation having a 4 independent variables. तर लक्षात घ्या, ही प्रोसिजर आहे, तुम्हाला माहित पाहिजे, हे थोडं व्यवस्थित वाचून नंतर लिहून घ्या. फर्स्ट ऑफ ऑल यू रीड दिस टोटल प्रोसेस, टोटल स्टेप्स. In place of capital F1 you put this h1, h2, h3, आणि हा पार्ट सुद्धा h1, h2, h3 च असतो. h1 मध्येच लिहा, h1, f1 means h1. You can take this, वाटलं तर इथं लिहा तुम्ही. You can take this h1. काही अडचण नाहीये, तुम्ही f1 जरी ठेवला तरी चालतं, किंवा आपण h1, h2, h3. आपण थेरम मध्ये थेरम h1, h2, h3 न प्रूव्ह केलं असल्यामुळं ही कंडिशन चेक करायची, थेरमची कंडिशन. इन द थर्ड स्टेप, दिस इज द स्टेप नंबर 3. इन दॅट थर्ड स्टेप वी हॅव टू चेक द कंडिशन ऑफ थेरम, दिस कंडिशन. इफ इट विल बी द 0, if it will be the 0, then we can solve f h1 h2. Here in this case, this step 3 tells us that if this will be the 0, then we can solve f, this f and h1, h2, h3. They are compatible. So, and put these values of P1, P2, P3, P4 in the Pfaffian differential equation, then we get the solution. These are the steps. हे steps तुम्ही व्यवस्थित नंतर लिहून घ्या. These are the steps फॉर फाइंडिंग द सोल्युशन ऑफ द डिफरन्शियल इक्वेशन. आता या स्टेपकडे न जाता आपण आणखी शॉर्टकटनं सोल्युशन पाहणार आहोत. वी हॅव टू सॉल्व द प्रॉब्लेम्स बेस्ड ऑन दिस. प्रत्यक्ष या स्टेप न करता सोल्युशन पाहू. नाउ फर्स्ट प्रॉब्लेम, दिस इज अ इम्पॉर्टंट प्रॉब्लेम. शो दॅट द कंप्लीट इंटिग्रल ऑफ f of ux, uy, uz which is equals to 0. If this integral, if a partial differential equation which is of the form f of ux, uy, uz which is equals to 0, that means if the function contains only the terms of ux, uy, uz, there is absence of x, y, z, then its solution will be definitely in the form of u is equals to ax plus by plus cz plus d. या स्वरूपात सोल्युशन असेल. इफ द पार्शियल डिफरेंशियल इक्वेशन इज इन द फॉर्म ओनली ux, uy, uz. यहाँ पे आपको नोट करना है, अगर पार्शियल डिफरेंशियल इक्वेशन ux, uy, uz यही टर्म होते हैं, x, y, z एब्सेंट होते हैं, तो उसका सॉल्यूशन u इज इक्वल टू ए एक्स प्लस बी वाई प्लस सी जेड प्लस डी इस तरह से आता है. ये हमें डिफाइन करना है. Also if f of a comma b comma c is equals to 0, if there is a function which having a term only a b c, if we replace this a b c, then f of a comma b comma c is equals to 0, then we can write the complete integral in terms of only three independent variables a b c. Okay, we shall prove this also. Now next, hence then we have to give one example in addition that, hence find the complete integral of this problem. On the basis of this first condition, we have to solve this example. Okay, now see this. Here given that f of ux, uy, uz which is equals to 0, we have, according to the step number second, write down the Jacobi's equation. Step first, given a function, write down the Jacobi equation. Now Jacobi's auxiliary equations are dx divided by fux, dy divided by fuy, dz divided by fuz, dux divided by minus fx, duy divided by minus fy, duz divided by minus fz. In this way, this is in terms of p1, p2, p3. But in terms of you can write in this way, Jacobi's auxiliary equation. In terms of x, y, z, ux, uy, uz. You can transfer this in terms of x1, y1, z, x1, x2, x3, x1, x2, x3. So fp1, fp2, fp3 in this way. There is no problem. So this is the Jacobi equation. Now from this equation we can say that here fx, partial derivative of f with respect to x is 0 because there is no any term of x. Fy will be 0. Fz will be 0 because x, y, z is absent in that given partial differential equation which is in the form of ux, uy, uz only. So put these values. आता पहा, fux आपण कॅल्क्युलेट करू शकत नाही, fuy कॅल्क्युलेट करू शकत नाही, तो फंक्शन दिलेला नाही. दिस इज अ जनरल फंक्शन. वी हॅव गिवन ओनली जनरल फंक्शन. सो by using this general function we can definitely say that fx is equals to 0, fy is equals to 0, fz is equals to 0. Put into, then we will get this. dx divided by fux, dy divided by fuy, dz divided by fuz, dux 0, duy upon 0, duz upon 0. So we can write this implies that dux is equals to 0, this implies that duy is equals to 0, this implies that duz is equals to 0. कुणीही सोबत लिहायचं नाही, फक्त मला आन्सर द्यायचे, सोबत कुणीच लिहायचं नाही. फ्रॉम दिस equation 3 we can write, suppose this is from this Jacobi's auxiliary equations we can write dux is equals to 0, duy is equals to 0, duz is equals to 0. After integrating, derivative will be get cancel. We will write ux, integration of 0, 0 च integration 0, and constant of integration is a. Similarly, integration of duy is uy, integration of 0 is 0, and constant of integration is b. Similarly, uz is equals to c. So put these values in the Pfaffian differential equation. What is that Pfaffian differential equation? That is gu is equals to u dx plus u dy plus u dz. So du is equals to a dx plus b dy plus c dx. By integrating, we can write du's integration u, a constant as it is, dx integration x, b as it is, dy's integration y, पुन्हा c derivative of dz c dz z, and constant of integration here. In this case, we have considered the constant of integration d. So this is the required solution. This is the required solution of this partial differential equation. If the partial differential equation is of the form ux, uy, uz, f of ux, uy, uz, which is equals to 0, then we have proved its solution is in this way: u is equals to ax plus by plus cz plus d. आणखी काय प्रूव्ह करायचं पहा? शो दॅट इट इज अ कंप्लीट इंटिग्रल. It is a complete integral. When we can say that it is a complete integral, here actually in this differential equation there are three independent variables. There are three independent variables. So solution requires three arbitrary constants. Solution requires three arbitrary constants. But here in this solution there are four arbitrary constants. There are four arbitrary constants. So we have to convert this solution in the four arbitrary constants. Okay. So actually in the first part we have proved this. हा फर्स्ट पार्ट आपण प्रूव्ह केलेला आहे. आता इथं परत ॲडिशन एक कंडिशन दिले, एफ ऑफ ए कॉमा बी कॉमा सी इज इक्वल्स टू 0 दिलेलं आहे. सो रिप्लेस दिस व्हॅल्यू. सो where a, b, c, d are constant, also given that f of a, b, c is equals to 0. Means इथं पहा f of a, b, c is equals to 0. मग इथं कंडिशन कशी दिलेली आहे? इथं आपण असं लिहू शकतो. So from this equation we can write, आता इथं this is a function in terms of a, b, c. This is in function in terms of a, b, c. So by using this, suppose I is like ab plus b plus c which is equals to 0. This is I is like f of a comma b comma c. By using this we can take the value of c. We can write c is equals to minus ab minus b. Then from this equation we can determine the value of c in terms of ab, and putting the value of c in the equation 3. इन द इक्वेशन 3 येणारी व्हॅल्यू सी ची जर तुम्ही इथं 3 मध्ये ए आणि बी च्या फॉर्म मध्ये लिहिलात, सी इन टर्म्स ऑफ ए बी, देन देयर विल बी ओनली 3 आर्बिट्ररी कॉन्स्टंट्स. विच आर दोज? ए बी अँड डी. दॅट मीन्स दिस विल बी द कंप्लीट सोल्युशन. मग नंतर ते कसं होतं? कंप्लीट सोल्युशन होतं. सो पुटिंग दिस व्हॅल्यू ऑफ सी इन 3, देन इट हॅज 3 आर्बिट्ररी कॉन्स्टंट्स. विच आर दोज? A, B, D. कारण independent variable 3 आहेत. You know that the condition of the solution of a partial differential equation or ordinary differential equation, if there are 3 independent variable, then solution must be maximum 3 arbitrary constant. But here there are 4 arbitrary constant. But according to this condition, f of a, b, c is equals to 0, we can find the value of c and replace the value of c here. Then we will get the solution in terms of a, b, d. That means there are again 3 arbitrary constants and it is the complete solution. Then it will be the complete solution and hence proved. अशा पद्धतीने हे प्रूफ कंप्लीट होतं. 3 आर्बिट्ररी कॉन्स्टंट झाल्यानंतर कंप्लीट सोल्युशन होतं. आता जो दुसरा पार्ट आहे, सेकंड पार्ट कुठला आहे पहा? हेन्स फाइंड द कंप्लीट इंटिग्रल ऑफ, वी हॅव टू सॉल्व दिस प्रॉब्लेम, ux प्लस uy प्लस uz मायनस ux इंटू uy इंटू uz इज इक्वल्स टू 0. हा सेकंड पार्ट आहे. इन दॅट सेकंड पार्ट वी शॅल मूव्ह टुवर्ड्स. Now in this second part, this is the first part, hence proved, means this is the first part. Now in the second part we have to calculate complete integral of the partial differential equation. We have given this partial differential equation, ux plus uy plus uz minus ux into uy into uz, which is equals to 0. Now compare this in the general partial differential equation, f of ux comma uy comma uz, or you can compare in this way also, f of x comma y comma z ux uy uz you can take. okay, असं सुद्धा कंपेअर करू शकता, काही अडचण नाही आहे. सो नाव फ्रॉम 1 and 2, now this is a function only in terms of ux uy uz, then we can say that, definitely we can say that ux is equals to a, uy is equals to b, uz is equals to c. If we take from 1 and 2, if we replace this value in the auxiliary differential equation, then in this case definitely we can say that fx is equals to 0, fy is equals to 0, fz is equals to 0. In this case fx is equals to 0, fy is equals to 0, fz is equals to 0. If we put these values in the Jacobi's auxiliary equations, then we will get ux is equals to a, uy is equals to b, uz is equals to c. Already we have solved in this problem, so we have taken directly. Now put ux is equals to a, uy is equals to b, uz is equals to c in this equation, that is in this equation number 5. So put in 5, so a plus b plus c minus abc. So we can write, transfer this a on left side, b on right side. So c minus abc is equals to a minus b. Take out a c common, c in a bracket 1 minus ab is equals to minus a minus b. So c is equals to minus in a bracket a plus b divided by 1 minus ab. So minus common काढून cancel करा, c is equals to a plus b upon ab. Now we know that ux is given, uy is given, uz is given, and value of c is already known. So putting these values in Pfaffian differential equation, so what is that Pfaffian differential equation? Du is equals to ux dx uy dy uz dz. Ux means a, uy means b, uz means c. By integrating, u is equals to ax by cz d. But we can't say this is a complete solution because it includes 4 arbitrary constants. But in the given problem there are only 3 independent variables. Here are 4 arbitrary constants. So to convert this in the complete solution we need 3 arbitrary constants. So replace the value of c. C म्हणजे किती आहे? a plus b divided by ab minus 1. So replace the value of c from 6. From 6 c ची व्हॅल्यू रिप्लेस करा. सो दिस इज द रिक्वायर्ड सोल्युशन. मला सांगा बरे या सोल्युशन मध्ये किती आर्बिट्ररी कॉन्स्टंट्स आहेत? हाऊ मेनी आर्बिट्ररी कॉन्स्टंट्स आर देअर इन दिस इक्वेशन? देअर आर 3 आर्बिट्ररी कॉन्स्टंट्स a, b and d. So this is the complete solution of given partial differential equation 5. The complete solution of this partial differential equation is this. अशा पद्धतीनं हा complete होतो. Okay, so this completes from 6. Is it okay? समजला ना तुम्हाला? हा खूप इजी आहे, काही अवघड नाही आहे. सेकंड, सॉल्व द सद्दाम है क्या? सद्दाम समझ में आया क्या रे? सद्दाम, मोहिनी काळे, माळी, मनीषा माळी, गाडेकर, सारिका पराळे, पूजा, ऋतुजा, रचना, संगीता, नेहा काळे, संभाजी जाधव है, सद्दाम भी है, नाज इमरान, समरीन खान, सारिका बोळेगावे. व्हेरी गुड. Now we shall move towards the second problem. प्रॉब्लेम समजला का रे सर्वांना? इफ यू हॅव एनी डाउट देन यू कॅन आस्क. सॉल्व partial equation. Now we have to solve this partial differential equation by the Jacobi's method. We have to use the same procedure, same step. Which are those? First of all, consider this given differential equation in the general form f of x comma y comma z comma ux uy uz. Then write down the Jacobi's auxiliary equation. Put the values in Jacobi's auxiliary equation, and by using that auxiliary equation calculate ux, uy, uz. Put these values of ux, uy, uz in the Pfaffian differential equation and solve that Pfaffian differential equation, then you will get the solution. Okay, there is no any alternative method. We can solve all these as like Charpit's method. We have to use the Jacobi's method. But in this case there may be exist 3 or more independent variables. Okay, now given differential equation is, we can write in the form of f of x comma y comma z ux uy uz, which is equals to z square plus zuz minus ux square minus uy square, which is equals to 0. Suppose this is equation number 1. Now we have the Jacobi's auxiliary equations are dx divided by fux, dy divided by fuy, dz divided by fuz, dux divided by minus fx, duy minus divided minus fy, duz divided by minus fz. Now we know that according to this equation, student सांगा बरे मला या इक्वेशन वरनं fx किती येतो? fx here याच्यावरनं सांगा मला fx, how we can calculate fx. So here fx will be 0 because there is no any term of x. परत fy सांगा रे किती येतो? fy will be 0. आता fz ची व्हॅल्यू सांगा. चला रे फास्ट आन्सर द्या. We have to differentiate with respect to x, means fx, but on the right side there is no any x term, so its partial derivative will be 0. Fy, differentiate this f with respect to y, but on the right side there is no any y term, so it will be 0. Now you tell me fz 0 नाही सांगत. चला आन्सर कम्प्लिटली चला म्हणजे मला लक्षात येतो तुम्ही कशाचा आन्सर सांगताय. नाउ यू टेल मी fz, व्हॉट इज द व्हॅल्यू ऑफ fz? partial derivative of z with respect to f with respect to z, but there is a term on right side that is fz. fz चा derivative, z square चा derivative to 2z, there is again term of z into uz, so 2z plus uz. This is the value of fz. Is it okay? Okay, 2z plus uz. आता मला सांगा बरे fux किती येतो? Also fux मी डायरेक्ट लिहिलं, आता बऱ्याच वेळा झालं म्हणून डायरेक्ट लिहिलेलं आहे, लक्षात घ्या. 2z प्लस uz येतं सद्दाम. 2z प्लस z स्क्वेअरचा 2z आणि झडच्या 2 टर्म आहेत. ॲक्च्युअली यहाँ पे 2 टर्म्स आहे z सो uz झडचा 1 येतो uz. आता fux, नाउ यू टेल मी fux partial derivative of f with respect to ux. Here is ux square, so we can write minus 2ux. And similarly fuy means there is a minus uy square, so minus 2uy. Okay, and uz किती येतो रे? fuz means there is a term of uz is here, so it will be z. So fuz will be z. अशा पद्धतीने आता. Now putting all these values here in the auxiliary equation, so we can write fux means minus 2ux, fuy याचा डेरिव्हेटिव्ह घ्या means minus 2uy, fuz means here is a fuz चा डेरिव्हेटिव्ह 1, so z इथं येतो z. अगेन fx means 0, fy means 0, fz means 0. Sorry, fz means minus 2u minus uz. माइनस न मल्टिप्लाय करा. डू यू अंडरस्टँड दिस? ओके, हां, व्हेरी गुड. सुप्रिया गाडेकर, मनीषा माळी, गायकवाड, मायावती, वाकडे, संगीता, नेहा, ऋतुजा, व्हेरी गुड. रवीना, व्हेरी गुड. योगेश गोडके, ओके राईट. समजलं ना हे कसं आलं. नाव वी हॅव टू टेक the terms this and this. It is easy to solve. So from these means from fourth and fifth fraction we can write, taking fourth and fifth fraction, that is dou ux by 0 which is equals to dou u by 0. That means dux is equals to 0, dux is equals to 0, duy is equals to 0. By integrating, after integration, ux is equals to a, uy is equals to b. समजलं का हे कसं आलं. ux is equals to a, uy is equals to b. Now put these values of ux and uy in equation 1 मध्ये ठेवा. So it will be z square plus z into uz minus ux square minus uy square is equals to 0. This is equation 1, number 1. Put ux is equals to a, uy is equals to b. So from this you can calculate z. So z square plus z into uz which is equals to a square plus b square. So z into uz is equals to a square plus b square minus z square in this way. So we can write uz is equals to a square plus b square minus z square upon z square. In this way we have calculated ux, uy and uz. So putting these values of ux, uy, uz in the Pfaffian differential equation. So it is denoted by du is equals to ux dx plus uy dy plus uz dz. Ux means a, uy means b, and uz means from equation 4 we can write a square plus b square minus z square upon z dz. Now we can calculate the integration here directly. But before solving the integration, you have to write this third term on right side in the clear form, in the perfect form. So separate this denominator z. So we can write a square plus b square divided by z, and this minus z square divided by z means we can write z. So we have converted in this way, simplified form, because we can take the integration directly. Now by integration or by integrating, du च integration u, a is a constant, integration it's with respect to x is x, b च integration, b is a constant, integration with respect to y is by. Again here integrating with respect to z, a square plus b square is a constant, 1 upon z चा integration with respect to z is log z minus, आता हेच, this is the integration, a square plus b square as it is, 1 upon z चं integration with respect to z log z. Again z चं integration काय आहे तर integration of z is z square by 2 plus here there are only two arbitrary constant a, b, and the third arbitrary constant is c for this integral. For this integration, due to this integration, we can take c as arbitrary constant. Now check this solution. In this solution there are how many arbitrary constants? Student मला सांगा बरे, fast सांगा. This is the solution, but we have to say it is a complete solution. Now how many arbitrary constants are there in this equation? चलो रे student सांगा ना, how many arbitrary constants? In this equation there are three arbitrary constants, a, b, ab and c. That means there are three arbitrary constants. In our problem, the partial differential equation having three independent variables, the solution having three arbitrary constants, so hence it is the complete solution or complete integral of a given partial differential equation 1. Okay. Yes, very nice. मोहिनी काळे, सारिका पराळे, ऋतुजा, आज्ञा, ढोले निलेश, मनीषा माळी, नाज, रचना, ऋतिका, प्रीति, अनुराधा, नितिन पवार, सुप्रिया, राधा, पूजा. ओके, व्हेरी नाइस. डू यू अंडरस्टँड दिस? हे समजलं का रे तुम्हाला? Saddam, Imran, Naz, okay, Sambhaji Jadhav, Gaikwad, Samrin Khan, Pragati Patil, very good. समजलं का रे सर्वांना? डू यू अंडरस्टँड दिस सोल्युशन मेथड? खूप इझी आहे, फक्त प्रोसेस समजून घ्या. हे एफ एक्स, एफ यू एक्स, एफ यू वाय, you must understand this, how we can calculate from this equation. Okay, now we shall move towards the next problem. Third problem, solve by Jacobi method z plus 2 times of uz minus ux plus uy bracket square plus 0. You can write this in this way also. याला असं सुद्धा लिहिता येईल. For the derivative purpose, z plus 2uz minus ux square minus 2ux uy minus uy square, which is equals to 0. Means we can take in this way also. For the derivative purpose, we can expand this bracket square. Now let given partial differential equation is in the form f of x comma y comma z ux uy uz, which is equals to z plus 2uz minus ux plus uy bracket square is equals to 0, or you can write in this way. कशाही पद्धतीने लिहा, there is no any problem. Okay, now Jacobi's auxiliary equations are dx divided by f ux, which is equals to dy by f uy equals to dz by f uz, dux divided by minus fx, duy divided by minus fy, duz divided by minus fz. So now we have to calculate. हाँ, मला सांगा रे स्टुडंट्स, fx किती? चला फास्ट सांगायचं आता प्रत्येकाने. fx first you have to calculate fx. How we can write fx? Fx is 0 because there is no any term on the right side fx. Then you can calculate fy. Fy is no any term of y on the right side, so fy will be 0. हाँ, सांगा फास्ट, fz ची व्हॅल्यू किती येईल रे? fz. So fz, there is a term on right side. There is only one term on right side, fz. Z, it is a z. Derivative of f with respect to z is 1, so we can write it 1. So first of all we have calculated fx, fy, fz. Now fux. Now from this you can write fux, or this you can write fux. There is a bracket square, ux plus uy bracket square. So fux means very good. Swapnil Sarvodaya, Adnya, Nikita, Nitin Pawar, right, Rachna Bhagwat, Manisha Mali. Okay, fux means how we can take it is the bracket square. So in the bracket you can take a bracket in square in a multiplication and bracket to the power 1. So minus 2 in a bracket ux plus uy. Again derivative of ux with respect to ux is 1. So we can write fux is equals to minus 2 times of ux plus uy. Ux plus uy. Okay. Now we can write fuy. Now there is a uy, but there is a bracket square. So differentiating f with respect to uy means minus 2 times. Take this bracket in a multiplication. So ux plus uy, ux plus uy. Hello, मी क्लास मध्ये आहे, मी लावतो थोडा आता. Okay, so we can write this. So we can write this fuy is equals to minus 2 ux plus uy in this way. And uz, you tell me student, what is the value of fuz? Now in this total problem, uz is here. Derivative of uz with respect to uz is 1. So 2 into 1 means 2. So f uz is 2. Putting all these values in the, so put all these values in this auxiliary equation. So we can write this. So our auxiliary equation becomes, Jacobi's auxiliary equation becomes this. Okay. Now here in this case we can solve easily, which first, second, third, fourth and fifth. Fourth and fifth fraction we can solve easily. So you can take these two. So from this, from 3 we can write dux is equals to 0, duy is equals to 0. This implies that by integrating we can write this ux is equals to a, uy is equals to b. But we have to calculate uz also. We have to calculate uz also. So put the value of ux which is equals to a, uy which is equals to b in equation 1. So this equation 1 becomes z plus 2uz, see this, z plus 2uz minus in a bracket ux square, ux plus uy bracket square means a plus b bracket square. So replace this value ab. So you can transfer this on right side, this transfer on right side. So 2uz is equals to a plus b bracket square minus z. So uz is equals to, you can write a plus b bracket square minus z upon 2. In this way we can obtain uz, ux, uy. Is it okay? समझला का? How we have calculated here ux, uy, uz. Now putting these all values in equation, that is a Pfaffian form. So du is equals to ux dx plus uy dy plus uz dz. Then du is equals to a dx, b dy, and put this uz means a plus b bracket square upon 2 minus z dz. Now you can integrate this. You can integrate this easily. So du चा integration u, ax plus by, adx चा integration ax, bdy चा integration by. This is a constant. A plus b bracket square divided by 2 is a constant. Constant चा derivative with respect to z means a plus b bracket square divided by 2 into z minus पुन्हा z चा derivative z square by 2. So we have to take in the 2 step. So it will be integration is, याचा integration कसा येतं, a plus b bracket square divided by 2. Integration of this term with respect to z is a plus b bracket square divided by 2 into z. So this again z चा integration z square by 2. आता मला सांगा रे, how many arbitrary constants are there in this equation? Student, for the complete integration you must need that maximum 3 constants if there are 3 independent variables. So in this equation there are 3 constants a, b, c. Here c is the integration constant, last c. So this is the complete integration. Okay. Now again we shall move towards the fourth problem. We shall solve this. ux square plus uy square plus uz which is equals to 1. Which is equals to 1. So the Jacobi's method is let same problem f ux uy uz. So first of all calculate. आता मला या फंक्शन वरनं सर्वांनी फास्ट कॅल्क्युलेट करून सांगायचे आहे. How many we can write fx? Now you tell me students the value of fx. According to this given equation, transfer this one on left side, so right side will be 0, so we can write f of 0 form. We can write f of 0 form. So fx is 0, fy is 0, fz is equals to again 0, because there is no any term of x, y, z in this equation. Okay, Radha Kale, very good. Adnya, Sarika, Manisha, Patil Sirsagar, Preeti Sirsagar, okay. So we will get fx, fy, fz will be 0. Now we shall move towards fux. Fux, There is a ux square, so its derivative is 2ux. Is it okay? Again we have to calculate fuy. So uy square, so 2uy. Again we have to calculate fuz. That is uz is 1, so it will be 1. uz ची टर्म सिंपल आहे, स्क्वेअर नाही आहे, म्हणून 1 येतो. व्हेरी गुड. अनुराधा गिरी, संगीता, नेहा, समरीन, नागेश, मनीषा, Saddam, okay, very good. Yes, okay. Now putting these values in the Jacobi's auxiliary equation, then we can solve this. From this equation 3 we can take this. So dux, from this we can write dux upon 0 means ux is equals to 0, duy is equals to 0, duz is equals to 0. So this dux is equals to 0, duy is equals to 0, duz is equals to 0. By integrating dux integration ux, 0 integration 0, constant of integration is here a. By integration of the second equation, uy is equals to b, uz is equals to c. So putting these values of ux, uy, uz in equation 1, so we can write a square plus b square plus c square minus 1. So we can write this a square plus b square plus c is equals to 1. So c is equals to 1 minus a square plus b square. Because we have to convert in the 3 arbitrary constants, so we can calculate c in the form of a and b. Now we have the Pfaffian differential equation of the form du is equals to ux dx plus uy dy plus uz dz. Ux means a dx, uy means b dy, uz means c dz, but c is 1 minus a square plus b square. Is it okay? 1 minus in a bracket, students, I think, in a bracket. Or we can write 1 minus a square minus b square असे येईल. इथं करेक्शन करा थोडं, because you can take a square minus b square minus. Okay. So now you can integrate this. Du च integration u d ax by a square minus b square, these are the constants, and this integration with respect to dz is z. So 1 minus a square minus b square dz, and this integration constant of this equation is d. Now check the answer. How many arbitrary constants are there? There are 3 arbitrary constants. So this is the complete solution. Okay, इथं थोडं करेक्शन करा. Do this correction. Okay, do you understand this? समजलं का रे सर्वांना? So you can solve this homework. Assignment ला हे 2 प्रॉब्लेम सॉल्व करा. आणखी कंटिन्यू करू का रे स्टुडंट्स? कंटिन्यू करू का? थोडे 5-10 मिनिटाचा आहे, म्हणजे आपली जॅकोबी मेथड संपून जाईल. Shall we continue to complete the Jacobi method, because there are only 2-3 problems remaining. If you are interested, then I shall continue. Okay, we shall continue. Okay. Now this is the second part. Solution of a partial differential equation in 2 independent variables. If there are 2 independent variables, then the solution of a partial differential equation using Jacobi's method. Actually we know that Jacobi method is for, so Jacobi method is used to solve the 3 or more independent variables. 3 or more independent variables. Then what is about 2 independent variables? So in this section we shall discuss how to solve the partial differential equation which having 2 independent variable, x and y, and z is a dependent variable, by using the Jacobi method. You can solve it by Charpit's method, but it is also possible to solve this equation by the Jacobi method. But you have to consider this data, you have to consider this information. Suppose consider the partial differential equation having a two independent variable x and y. Z is a dependent variable denoted by f of x comma y comma z p comma q which is equals to 0. Now we have the solution 1 is the relation between x and y and z. याचा solution म्हणजे relation between x and y and z, and this relation will be in the form of u of x comma y comma z which is equals to c. याचा सोल्युशन कुठलंही डिफरन्शियल इक्वेशन तुम्ही लॅग्रांजियन मेथडनं सॉल्व्ह केलं असेल तर त्यात सुद्धा पहा सोल्युशन हे एक्स वाय झेडच्या फॉर्ममध्ये असतं, विच इज ऑफ द फॉर्म अँड अ कॉन्स्टंट हिअर सी. नाउ वी नो दॅट ही थेरी तुम्हाला माहीत आहे. पी मीन्स व्हॉट इज द पी? पी मीन्स डो यू डो झेड बाय डो यू डो एक्स. ॲक्च्युअली पी मीन्स डो झेड बाय डो एक्स means p. So we can write this p in the form of u. आता हे थेरम आहे झालेला आहे अगोदर. आता डायरेक्ट लक्षात ठेवा हे मायनस कसं आलं, बिकॉज वी हॅव युज्ड द इनवर्स थेरम ऑफ अ पार्शियल डिफरन्शियल इक्वेशन. सो वी कॅन राईट p इज इक्वल्स टू डो यू बाय डो एक्स डिवाइड बाय डो यू बाय डो झेड. दिस इज द रेसिप्रोकल फॉर्म. सो you do you it will be the get cancel dou z by dou x after taking the reciprocal, but here we have to take minus u. पण कंडिशन इथं मायनस यू चे रेसिप्रोकल घेत असताना एक थेरम आहे वेगळा, पण लक्षात ठेवा p इज इक्वल्स टू मायनस यू एक्स अपॉन यू झेड. यू कॅन राईट डो यू बाय डो एक्स मीन्स यू एक्स डिवाइड बाय डो यू बाय डो झेड मीन्स यू झेड. सो q इज इक्वल्स टू uy upon uz. Similarly, q means dou z by dou y, but you can write in the parametric theorem form in the partial differential equation minus. काही वेळेस प्लस सुद्धा येतं. Sometimes you can take plus also according to the given condition, but you note that these two important condition we can express p which is in the form of minus ux divided by uz. q we can write minus uy upon uz. So we can write p is equals to minus ux upon uz, q is equals to minus uy upon uz. You can take plus also for under some consideration. Okay, the term कशी आहे त्याच्यावर नसतं. Putting these values in equation 1, जर या व्हॅल्यू इक्वेशन 1 मध्ये ठेवलात, then we will get p in terms of ux upon uz, uy upon uz. So we will get the function x, y, z, ux, uy, and in this case u will be the constant. U of x is c. Okay, so u will be the c. Now this is the differential equation which is in the form of first equation. First या फॉर्म मध्ये तो x, y, z, ux, uy, uz. Now we can solve this differential equation by using the Jacobi method, and its solution will be u is equals to f of x comma y comma z comma a comma b plus c. You can replace this c as u. Okay, now see this example based on this. How we can solve? Find a complete integral of the equation p square x plus q square y which is equals to z. Given equation is p square x plus q square y which is equals to z. Here in this case p and q are the partial derivatives of z with respect to x and y. That means there are only two independent variables x and y. So replace this. P is equals to minus ux upon uz, q is equals to minus uy upon uz in equation 1. So we can write minus ux upon uz bracket square. इथं ठेवा p ची व्हॅल्यू, p ची व्हॅल्यू, q ची व्हॅल्यू. सो मायनस uy upon uz ब्रॅकेट स्क्वेअर, स्क्वेअरिंग करा, मायनसचा स्क्वेअर होतो स्क्वेअर. सो x into ux square upon uz square plus uy square upon uz square into y equals to z. Multiplying by uz square, then we will get x ux square plus y uy square plus z uz square. So we can write this. Now we can solve this equation in the form of a Pfaffian differential equation. Sorry, in the form of a Jacobi's differential equation. here we consider Z as another independent variable. Z is another independent variable. We have converted this. Z is independent variable and U is dependent variable. In this case, U is a dependent variable, X, Y, Z are independent variable because we have converted this in terms of Ux divided by Uz. So, now same process na आता solve करा. Now we have to use the Jacobi's method for the solution of this equation. So compare this in the general form, f of x comma y comma z ux uy uz, which is equals to x into ux square y into uy square minus z into uz square is equals to 0. This is the Jacobi's auxiliary equation. Now आता इथं तुम्हाला परत ते समजणं गरजेचं आहे. सर्वात महत्वाचं है, यहाँ पे आपको करेक्ट वैल्यू अगर निकालने को आता है एफ एक्स एफ वाई एफ जेड, नाउ यू टेल मी एफ एक्स एफ वाई एफ जेड एफ यू एक्स एफ यू वाई एफ यू जेड, इफ it is possible for you to find the correct values of x, fx, fy, fz, fux, fuy, fuz, then there will be the possible to find the correct solution. Unless we can't find the correct solution, इतना जर तुम्हारा correct value यहाँ पर ही अगर आपको correct value नहीं निकालने को आता है तो correct solution नहीं होता है. चलो बताओ रे students, what is the value of fx? Fx means here in this case there is only term of x into ux square, so its partial derivative with respect to x is x derivative 1 ux square as it is, so ux square. Fy which is equals to काय येतो आता uy square, is it okay? fz, z ची टर्म इथं आहे, fx नितीन हां ओके, कसं आहे अरे झिरो कसं येतं fx झिरो, मोहिनी काळे वाडेवाले झिरो नाही येणार, कसं येतात झिरो, एक्सच्या टर्म आहेत ना इथं, एक्सची टर्म आहे, वायची टर्म आहे, झेडची टर्म आहे, झिरो कसे येतील, जर टर्म नसतील तरच झिरो येतात. समरीन खान करेक्ट. एक्सची टर्म वायची टर्म जर ॲब्सेंट असेल तरच झिरो येतात. तुम्ही डायरेक्ट झिरो लिहिताय. ओके, एफ झेड इज इक्वल्स टू मायनस 2uz स्क्वेअर. दिस इज द व्हॅल्यू ऑफ एफ एक्स एफ वाय एफ झेड. समजते का सुप्रिया? चेक करत चला, म्हणून तर म्हणतो मी त्या जर व्हॅल्यू करेक्ट कॅल्क्युलेट करता आलं तरच पुढचं सोल्युशन येतं, नाहीतर सोल्युशन येत नाही. तुमचं लक्ष किती दिवस झालं कुठं आहे? हां, जरा लक्ष देत जावा रे विद्यार्थ्यांनो, हा खूप महत्त्वाचा आहे पार्ट. तुम्ही सुट्ट्यामध्ये तुमचं लक्ष नाही आहे. सो वी कॅन राईट एफ एक्स एफ वाय एफ झेड. बरोबर आहे का रे? सो दिस इज द बरोबर आहे का? तुमचं बऱ्याच जणांचं चुकलं रे. किती जणांचं चुकलं? काय करता तुम्ही सुट्ट्यामध्ये? पहा, प्रीती क्षीरसागर चुकलेला आहे. तुम्ही सर्व जनरल प्रॉब्लेम सारखंच घेताय. नेहा गायकवाड, नेहा मोरे, सर्वांचं चुकलेलं आहे. असं काय काढता तुम्ही? काय केलात? बऱ्याच जणांचं काय नुसतं सुट्ट्यामध्ये तुम्ही नुसतं एन्जॉयच करतात कॉलेज नसल्यामुळं. आणि मी पाहतो बऱ्याच जणांना नुसतं विद्यार्थी हेच गाणं म्हणतात, माझा तू होशील का, माझा तू होशील का. प्रत्येकाच्या विद्यार्थ्याच्या रिंगटोन तेच आहेत. सध्या मी मुलींचे तर पाहतो सर्व तेच चालू आहेत. अभ्यासाकडं कुणाचंच लक्ष नाही. सिरियलमुळं विद्यार्थी एवढे बिघडून गेलेले आहेत. मुलं असो, फॅमिली असो, सर्व सिरियल पाहून नुसते बिघडलेले आहेत. अभ्यासाकडं कुणाचं लक्ष नाही, काही नाही. साधा डेरिव्हेटिव्हचा प्रश्न येत नाही. आणि रिंगटोन पाहिलं की माझा तू होशील का, माझा तू होशील का. हो बरोबर आहे का रे? सर्वांची रिंगटोन मुलींची मॅक्झिमम मी पाहतो तीच असते. करेक्ट आहे का? सांगा बरे, कुणाकुणाला आवडतं? खरं सांगायचं, कुणाला आवडतं हे गाणं? खरं सांगायचं. ज्या ज्या विद्यार्थी असतात ना आवडतं ते नाही हात वर करा. कुणाला आवडतं? सर्वांना आवडतं है ना? बरोबर आहे का रे? काळे, पवार, माळी है ना, आवडतात तुम्हाला हे गाणे आवडतात का? कुणाला आवडतं प्रामाणिक सांगायचं, हे कुणाला आवडतं? सर्वांना आवडतं. मी पाहतो सिरियलमुळं सर्व बिघडून गेलं, वातावरणच बिघडून गेलेलं आहे. शिक्षणाचं वातावरण राहिलेलं आहे काय नाही. घरी बसतात, आवडतं तुम्हाला आवडतं. आवडत नाही का? राधा काळे आवडत नाही का? हां बरोबर आहे. कशाला आवडतं रे? आवडणार नाही खरंच. आता उन्हाळा निघून गेला, आवडून तरी काय फायदा आहे? हो ना, आवडत नाही, बरोबर आहे. उन्हाळा झाला म्हणून आवडत नसेल आता, कारण सीझन निघून गेलं ना, कशाला आवडतं मग? ओके ठीक आहे. तर लक्ष द्या जरा, बघा जरा, साध्या डेरिव्हेटिव्हच्या टर्म आहेत. या डेरिव्हेटिव्हच्या टर्म आल्याशिवाय पुढचा टर्म तुम्हाला येणारच नाही, लक्षात घ्या. डेरिव्हेटिव्हचा टर्म हो आवडत नाही. अनुराधागिरी, मला लक्षात आलं तुला आवडत नाही. अनुराधागिरीलाही आवडत नाही. नितीन मुलांना नाही आवडत, मुलींना आवडतं. नितीन पवार तुला कशाला आवडतं रे? माझा तू होशील का? तू नितीन पवारला कशाला आवडेल बरं का ना? मुलीला आवडत नाही. हा हो. ओके, सो वी शॅल राईट धिस. तर हे करेक्ट कॅल्क्युलेशन करा. जाऊ द्या, आवडीनिवडीचा प्रश्न सोडून द्या. सिरियल जास्त पाहत जाऊ नका, माझं सांगण्याचा उद्देश आहे. आवडणार नाही आहे तर नाही, ठीक आहे. आपण आता हे सोल्युशन पहा. हे डिफरन्शियल इक्वेशन सॉल्व्ह झाल्याशिवाय, हे सोल्युशन आल्याशिवाय, हे परफेक्ट आल्याशिवाय पुढचा पार्टच येत नाही. म्हणून हे खूप महत्त्वाचं आहे. ज्यांना येत नाही ना, ज्यांना हे समजत नाही, त्यांनी आपल्या एका फ्रेंडजवळ बसा, कुठल्या तरी एका फ्रेंडजवळ जावा. ज्यांना डेरिव्हेटिव्हच्या टर्म समजत नाही आहेत, ज्यांना डेरिव्हेटिव्हच्या टर्म कळत नाही आहेत, त्यांनी एखाद्या फ्रेंडजवळ बसा आणि त्यांच्याकडनं या डेरिव्हेटिव्हच्या टर्म समजून घ्या. ओके, माझ्यापर्यंत पण यायची गरज नाही आहे. ज्यांना जमतं ना त्यांच्याकडनं समजून घ्या. ओके ठीक आहे. सो वी कॅन पुट द व्हॅल्यूज ऑफ दिस इज ux uy fx fux fy fuz ux uy uz टेकिंग. नाउ चेक दिस. आता हा खूप महत्त्वाचा आहे, पहा. नाउ चेक दिस. dx first and fourth. Taking first and fourth fractions. आता फर्स्ट कुठला आहे? dx divided by 2x ux which is equals to dux divided by minus ux square. So this one ux will be get cancelled. So dx divided by 2x which is equals to dux divided by minus ux. Now you can take 2 on the right side. So it will be dx upon x is equals to minus 2 dux divided by ux. Now by integrating, आता याचं इंटिग्रेशन घ्या. So dx upon x चं इंटिग्रेशन काय असेल रे स्टुडंट्स? नाउ यू टेल मी. dx upon x चं इंटिग्रेशन. So dx upon x चं इंटिग्रेशन log x which is equals to du upon ux means minus 2 log u plus we shall consider the constant of integration in terms of a log. So transfer this on left side. You can take this on index. So ux square plus log a. You can take on the left side. So log x plus log of ux square which is equals to log a. So log of x into ux square is equals to log a. Log cancel होतं. x into ux square is equals to a. So ux square is equals to a divided by x. So we can find the value of ux in this way. हा प्रॉब्लेम समजून घ्या, खूप इंटरेस्टिंग आहे. व्हेरी गुड. सो ux is equals to root of a by x. समजलं का सद्दाम? ओके. So thus we have obtained here ux which is equals to root of a divided by x. Again we have to calculate uy and uz. Now also similarly you can take second and fifth. Also we have to take second and fifth fraction because here is no zero. इथं कुठला झिरो नाही आहे. इथला कुठलाच सेकंड फ्रॅक्शन झिरो नसल्यामुळे आपल्याला अशी ॲडजस्टमेंट करावं लागते. सो वी कॅन टेक दिस सेकंड अँड फिफ्थ. सो again also taking second and fifth fractions of 3. So dy divided by 2y into uy which is equals to duy divided by minus uy square. So this will be the get cancel. Dy divided by y is equals to minus 2 duy divided by uy. Again you can take the integration. So integration of dy upon y is log y minus 2y is it is integration of du upon duy upon uy is log uy plus log b. Now you can take 2 in the exponent form and this negative you can take on a positive. So log y plus log of uy bracket square is equals to log b. So this addition we can convert in the product, log of y into ui square is equals to log b. So y into ui square is equals to b, ui square is equals to b upon y, ui is equals to b upon y. In this way we have obtained ui and ux. Now if we put these values in equation 1 or sorry 2, या ज्या व्हॅल्यूज आहेत त्या इक्वेशन 2 मध्ये ठेवला तर वी कॅन ऑब्टेन द व्हॅल्यू ऑफ uz. So putting the value of ux and uy in equation 2, then we will get the uz because we have required uz also to put the values in Pfaffian differential equation form. So putting in equation 2, so आता हे जे ux आणि uy च्या व्हॅल्यू 2 मध्ये ठेवा. So x ux square plus y uy square minus z uz square is equals to 0. This is equation 2. Put the value of ux means ux is root a by x, so ux square means a by x plus y into b by y minus z uz square. So z uz square is equals to a plus b. X cancel होतो. So this x cancel, this y cancel, a plus b. You can take this a plus b. On the right side it will be the minus a minus b multiplying by minus, then we will get z is equals to z into uz square is equals to a plus b. So uz square is equals to a plus b upon z. So uz is equals to a plus b upon z. This is the another method to find the values of ux, uy, uz. Is it okay? Now put these values in the Pfaffian differential equation. Du is equals to ux dx plus uy dy plus uz dz. So you can replace this. Ux means root of a divided by x dx, b root of b divided by y dy, uz means root of a plus b upon z dz. आता पहा, see this here, root a as it is 1 upon root x. See this, we can write root of a by x, that means root a divided by root x. So root a as it is, we can take this in the numerator x raised to minus 1 by 2. Root means x raised to 1 by 2. Root a divided by x raised to 1 by 2 we can take in the numerator. So root a into x raised to minus 1 by 2. For the calculation of integration purpose, we have to convert this in the numerator form. Root a into x raised to minus 1 by 2, root b into x raised to minus 1 by 2, y into 1 by 2. Sorry. And similarly, root of a plus b into z raised to minus 1 by 2 dz. Now integrating this, du च integration u, root a as it is a constant, x raised to minus 1 by 2 च integration, x raised to n च integration, x raised to n plus 1 divided by n plus 1. So x raised to 1 by 2 upon 1 by 2, root b as it is y raised to 1 by 2 upon 1 by 2. काय तो root of a plus b z raised to 1 by 2 upon 1 by 2 plus we have to take this constant of integration as a c. So simplify this. So you 2 root ax plus root by plus root a plus b into z plus c. See this, x raised to 1 by 2 है ना, that can be written as root a into root x means root ax आणि हा 2 रेसिप्रोकल होतो. सो आता इथं महत्वाचा u means c. We have to consider u as a c because as per our theory, see this is our theory, we will get the solution u of x comma y comma z which is equals to c. That means we have to replace the value of c. So at the final stage we have to replace the value of c. So writing u is equals to c. मग u च्या जागी c ठेवलं इथं तर c will be get cancel. c will be get cancel. Then remaining term will be u च्या जागी replace करा c. Writing u is equals to c. then CC will be get cancelled, then 2 root of AX plus 2 root BY plus 2 root A plus B into Z, which is equals to C. Because we have considered, because in this case only there are two independent variable X and Y, and Z is a dependent variable. So we have to replace this U by using constant, that is C. So we can convert this. मग यालाच असं लिहिता येतं. So we can write this on right side, minus minus. So root Z is equals to this, root AX, root BX upon root AB. आता याला सेपरेट करा डिनॉमिनेटर, मीन्स AX डिवाइड बाय AB ब्रॅकेट रेस टू 1/2, BY डिवाइड बाय A प्लस B ब्रॅकेट रेस टू 1/2 रूटसाठी, आणि हा Z इथं होतं बाय स्क्वेअरिंग, हे रूट होतं ना, रूट झेडचा झेड केला त्याबद्दल ब्रॅकेटचा स्क्वेअर. दिस इज द रिक्वायर्ड सोल्युशन. आणि आता हा सोल्युशन चेक करा. हाऊ मेनी, सर्वात महत्त्वाचं इथं आहे पहा, हाऊ मेनी आर्बिट्ररी कॉन्स्टंट्स आर देअर इन दिस इक्वेशन. How many arbitrary constants are there in this equation? To say the complete solution, it is a very essential to check the arbitrary constants in the final equation, in the final solution. How many arbitrary constants are there in this equation? Here in this case, चला रे फास्ट सांगा, हे सोल्युशन स्टेप समजल्या का सर्वांना? कसं सॉल्व केलं? फक्त इथं लक्षात ठेवा, यू हा कन्सिडर केलेला होता, डिपेंडंट व्हेरिएबल आपण कन्सिडर केला होता. सो इन द फायनल जो जॅकोबीज इक्वेशनचं फायनल आन्सर आलं होतं ना, त्यामध्ये यू इज इक्वल्स टू सी ठेवा, म्हणजेच इट विल बी द कन्वर्टेड इन टू द टू इंडिपेंडंट व्हेरिएबल फॉर्म. ओके, व्हेरी गुड. राधा काळे, ढोले, सद्दाम, निकिता. येस, in this equation there are two arbitrary constants A and B. In this solution there are two arbitrary constants A and B. And our problem is, main problem is P square X plus Q square Y, which is equals to Z. There are two independent variables. If in the partial differential equation, if there are two independent variables, in the solution if there are two arbitrary constants, then we can say that it is the complete solution, it is the correct and complete solution. Hence we can say that this is the complete solution of equation 1. This is a, see this is a complete solution of, हा जो आहे ना, this is a complete solution of equation 2. This is a complete solution of equation 1. आता इथं पहा, in the equation U there are three arbitrary constant, but our problem, that is equation 2, our partial differential equation, here too it has a three independent variable x, y, z. So the solution will be three arbitrary constants A, B, C. Here this equation having two independent variable, therefore its solution is two arbitrary constants. समजतं का? समजलं ना तुम्हाला हे कन्सेप्ट? आर्बिट्ररी कॉन्स्टंट्स आणि पार्शियल डिफरन्शियल इक्वेशनचं सोल्युशनचा रिलेशन समजला का रे स्टुडंट्स? तुम्हाला सर्वांना समजलं का सांगा, हे महत्त्वाचं आहे. डू यू अंडरस्टँड दिस, द रिलेशन बिटवीन आर्बिट्ररी कॉन्स्टंट्स अँड द partial differential equations independent variable? Is it okay? So this completes the solution. मग हे होमवर्क करा, सेम अशाच पद्धतीने सॉल्व करा, सेम पद्धतीने. वी हॅव टू पुट हिंट, प्रत्येक प्रॉब्लेमची हिंट आहे पहा. पुट P is equals to minus ux upon uz, Q is equals to minus u upon uz. Okay, and then convert in three independent variable form. Convert in three independent variable form, solve by Jacobi, then solve by Jacobi, solve by Jacobi method. And number 4, put u is equals to c, then we will get complete solution. ऑफ दिस. या स्टेप लक्षात ठेवा, हिंट लक्षात ठेवा. पुट P इज इक्वल्स टू मायनस UX अपॉन UZ, Q इज इक्वल्स टू मायनस UY अपॉन UZ. कन्वर्ट इन द 3 इंडिपेंडंट व्हेरिएबल फॉर्म मीन्स UX UY UZ मध्ये. मग ते आलेलं इक्वेशन जॅकोबी इक्वेशननं सॉल्व करा. आलेल्या सोल्युशनमध्ये U इज इक्वल्स टू C ठेवा. मग परत त्याला सॉल्व करा. देन वी विल गेट द सोल्युशन इन टर्म्स ऑफ 2 इंडिपेंडंट टू आर्बिटरी कॉन्स्टंट्स अँड दिस इज द कंप्लीट रिक्वायर्ड सोल्युशन. ओके. तर ह्या सर्व कन्सेप्ट तुम्हाला समजल्या आहेत असं मला मान्य करतो. आणि अशा पद्धतीने हे जॅकोबी मेथड सॉल्व होते. अशा पद्धतीनं जॅकोबी मेथड सॉल्व करता येतो. तुम्ही वेगवेगळ्या पद्धतीनं आता जॅकोबी मेथड जर तुम्हाला सॉल्व करायची असेल तर परत त्याला 3 पेक्षा जास्त जर इंडिपेंडंट व्हेरिएबल असतील, इफ देर आर 4 इंडिपेंडंट व्हेरिएबल, इफ देर आर 5 इंडिपेंडंट व्हेरिएबल्स, then you have to use the same process. If there are 3 independent variables, if there are 4 independent variables, then you have to solve same process. किती इंडिपेंडंट व्हेरिएबल आहेत त्याच्यावरनं सेम प्रोसेस सॉल्व करा. फक्त त्यात तुम्ही ऑक्झिलरी इक्वेशन बदला. dx1 डिवाइड बाय fx1, dx2 डिवाइड बाय fx2, dx3 डिवाइड बाय fx3, dx4 by fx4, dx5 by fx5, then dp1, dp2, dp3 अशा पद्धतीनं सॉल्व करा. यू विल गेट द सोल्युशन. आणि एक लक्षात ठेवा, सर्वात महत्त्वाचं, यू मस्ट नोट दॅट इफ देर आर 5 इंडिपेंडंट व्हेरिएबल्स in the partial differential equation, then its solution includes 5 arbitrary constants. Its solutions include maximum 5 arbitrary constants. Okay, 6 arbitrary constant येत नाहीत, आले तर it is not a complete solution. Okay, so now we shall stop here. Namaskar, goodbye. काही जरी डाऊट आला तर विचारा. इफ यू हॅव एनी डाऊट, इफ यू हॅव एनी प्रॉब्लेम,